Hi guys, I want to look at the integral of sine to the power n of x dx. So we want to derive a reduction formula for sine, for powers of sine basically. So what we are going to do here is we're going to use the integrating by parts method. So in this case, what we need to do is to separate this. So we need to manipulate this here and change it to sine to the power n minus 1 of x multiplied by sine of x, right? So this is the same thing because this is sine to the power 1 by laws of indices. If these two are the same, the bases are the same, you can then add the powers, you get n minus 1 plus 1, which gives you sine to the power n of x. So what we are going to do here is we are going to let our u, so let u equals sine to the power n minus 1 of x. Then we use the power trig angle method. So this is the chain rule in disguise to derive this to find our du dx, right? So when we derive the power, we are going to get n minus 1. Basically, we are taking the power down, and then we are writing this as sine to the power. Now the new power, we are subtracting 1 there, right? So we get n minus 2 of x. Then we derive the trig. So we derive the trig. That's what this t stands for. If we derive sine, we get cos. So basically, if we derive sine, we just get cos. So we're going to get cos x, right? The angle, if we derive the angle, we have x. If we derive x, we get 1. So x with respect to x, we just get 1. No need to write that. So we now have du dx and our u. We can now say, our dv dx is automatically what's left of this integral. So what's left here is sine x. That becomes our dv dx. So dv dx is equal to sine of x, right? And our v is then the integral or the antiderivative of this derivative, right? So if we find the antiderivative, the integrating side gives us minus cos. So now we apply integrating by parts. We're going to say, so the formula says the integral of u dv dx. So this is the form of the question, right? We get uv minus the integral of v du over dx. So now what's going to happen is that we're going to plug in all these terms that we have. If we plug in this one and that one, it's u dv dx, right? That's just the integral of sine to the power n of x because it's actually that integral, which is just that. So with respect to x, uv is going to be that multiplied by that, which gives us minus sine to the power n minus 1 of x cos x. So minus cos x, we have it. Sine to the power n minus 1 of x, we have it. Now we say minus, right? It's this minus here. V du dx also has a negative inside. That negative belongs to v, right? So we can choose to write it outside and just put a plus there because we now have two negatives in the middle there. So what we're going to end up having is for our v du dx, actually we can also put that part as a outside because it's a constant. This part here, we can choose to put it outside. So let us put it here. So we now have n minus 1 integral of sine to the power n minus 2 of x. Then we have that cos x. We already took care of its negative side. We now have the cos x from there. We also have the cos x from that derivative. So that's going to give us a cos squared of x dx, right? So we now have something like this here. We now have something like this here. So what we are going to do here is we're going to rewrite this, and we're going to change this part using the identity. We know that cos squared x is equal to 1 minus sine squared of x. So we're going to make use of that, right? So what we're going to do is we're going to write sine to the n of x, nothing has changed here, dx equals minus sine to the n minus 1 of x cos x, right, plus n minus 1 integral of sine to the n minus 2, right, of x. Here we're going to put 1 minus sine squared of x dx. So we're going to have something like that. Now what we're going to do next is we're going to just expand this part. So nothing changes here, right? We're just going to expand that bracket there. So that's going to be sine to the n of x dx equals minus sine to the n minus 1 of x cos x, plus we expand that bracket. So basically we are multiplying this bracket with this constant, this part here, and the dx. So we are multiplying this term and this term with these things here outside. So what's going to happen here is that for the first one we're going to have plus n minus 1 integral of sine to the power n minus 2, right? So that's going to be to the power n minus 2 of x. Then we have what? We have a dx there, right? So we're going to put the dx there. Now we say minus because we have a negative there. That's going to be minus the integral of, we have to also put n minus 1, right? Because we have n minus 1 there. It's multiplying through. So that's going to be n minus 1. Then we're going to put the integral of what? That's going to be the integral of sine to the n. If you look at it now, we have sine to the n minus 2 of x and sine squared of x multiplying each other. So what does that do? Sine to the n minus 2 of x multiplied by sine squared of x. These bases are the same, right? So what we need to do is we need to just add the powers. So by laws of indices, our power becomes n minus 2 plus 2. This here is just 0, so we end up with sine to the power n of x dx. Now, this term here, let's compare this term with that term, right? If you look at this part here, if this here was a cow, this one is also a cow, right? So they are the same. Those parts are the same. So this one we have minus n minus 1 integrals of sine to the n of x dx. Here we have 1 integral of sine to the n of x dx. So we can actually transfer this to the other side, and if we do that, it becomes positive because it was negative on that side. So what are we adding? These are counts. We are adding this part here, right? So here we have 1, right? So if we add those, what's going to happen? We are going to end up with n. So we're going to end up with n minus 1 plus 1, isn't it? This here gives us what? Just gives us, because we have n minus 1, right? And we have a 1 there, so it just gives us n. So what's going to happen there is we're going to get an n integral of sine to the power n of x dx. So we're going to get something like this, right? And then we're going to get what? we are going to have that part as minus sine to the power n minus 1 of x cos x. Here we no longer have that part, so we can only write this part. So it's now plus n minus 1 integral of sine to the n minus 2 of x dx. Right? So that's the part that we just have. So now we were not asked for, we can see that here we have an n, right? But we're not asked for n integrals of sine to the power n of x with respect to x. We were asked for the integral, a single integral of sine to the power n of x dx. So we need to divide both sides by n to get rid of that n so that we end up having a 1 day. So if we do that, this here is going to be over n and that day is going to be over n. So we're going to have something like this. The integral of sine to the n of x dx is equal to minus 1 over n sine to the n minus 1 of x cos x plus n minus 1 over n integral of sine to the n minus 2 of x dx. So basically that's the reduction formula for sine to the power n of x dx.